Hello everyone, today we're going to look at usaco-training contact. Okay, so in this problem we're going to be given a pretty big string and we're going to find some patterns. And the pattern has some constraints, so it has to be at least length A and its length cannot be greater than B. So for example, in this problem we're given the length has to be at least 2 and it can't be greater than 4. So then a possible pattern would be, let's just say 0, 1, because it fulfills the requirements since it has a length of 2. So then we're going to list out the n highest frequencies of those patterns. So for example, it says that 100 occurs 12 times, so it occurs here, it also occurs here, it occurs here, and it also occurs in the rest of the string. So then we would mark the string 100, or the pattern 100, as 12 times. So as you can see over here, for 12 we have this pattern called 100. Okay. Oh yeah, and a pattern is basically just a substring of the sequence. Okay, so we have n. So we're going to list out the n highest frequencies in order of descending. So then, for example, 0, 0 would occur 23 times. So then we'd put that at the top. And for 15, it would occur, both 0, 1 and 1, 0 would occur 15 times. So then you would put this as well. And then we're basically just going to output the 6 per line, and then we just end with the new line. Okay. So basically, the length of the text we're going to search, so basically length of text, or the length of the string we're going to search is going to be at most 200,000. And we know that A and B is in the range from 1 to 12. So what we're going to do is that we can just loop through all possible substrings. So for example, let's just say right now we have, let's just say 0, 1, 0, 1, 0, 0, 1, 0, 0. Let's just say our A is 1, so A equals to 1 and B equals to 4. So what we're going to do is that we're going to loop through all the possible substrings. So then, for example, we're going to loop through this. Actually, let's use another color. So we have this substring because it has length 1. Over here as well. So what we're going to do is just that we just loop through all these substrings, and then we just increment the frequency of this string. So for example, right now we could call this our size would be equal to 1. And here's basically all our possible substrings. So then if we just increment the counter, then what we're going to end up with is we have our 0. We're going to have 1, 2, 3, 4, 5, 6. So then our 0 would be equal to 6. And then our 1 would be equal to 1, 2, 3. So this would be equal to 3. Okay. So then we're going to loop through if the size is equal to 2. So then let's actually first erase this. Okay. So for size 2, we're going to have, whoops. Okay, so we're going to have this. We're going to have this, 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 and this. So then, our frequency would be, for example, you can see that 0, 1, so 0, 1, you would have 1, 2, 3. So this would occur 3 times. And let's just say 0, 0, this would occur 1, 2 times. So then over here this would be equal to 2. And then you have, let's just say 1, 0. This would occur 1, 2, 3 times. And then you have 1, 1, which would occur 0 times, so just mark that as 0. So basically we just loop through these sizes from, basically size from 1, or basically it's not actually 1, it should be from 1, not 1, my bad. It should be from A, which in this case we have 1, to B. And then we just basically increment our counter for our specific string. So what we're going to do after this is that once we have these counters, we can actually form our frequencies. Since over here, this is basically our pattern, and here is our frequency. So then, after we calculate this table, we're going to loop through. Actually, let's use another color. Okay, so for each frequency, or for each pattern, we're going to insert the frequency with that pattern. So basically, we're going to have, let's just say, our answer. So answer of frequency, you would just insert your pattern. And since after you do this, we're just going to loop through all the frequencies from big to small, and then we're just going to print out the pattern. So then, after this, basically for each frequency, for example, over here we have 6, 3, 2, and 0. So for each frequency, we're going to just print the pattern, or what we're going to do here is that for each pattern, in answer of this frequency, then we're just going to print this pattern. Okay. So that's basically it for that. And let's actually start coding. Okay, so this is contact. Okay, so let's include bits. So we're going to have our A, B, and N. Okay, and then we're going to have our string. So let's call this string text. So we can have our temporary strings because the text would actually come in many lines. So basically it would be string temp. So we're just going to do while get line. This would be cn, and this would be temp. We're just going to push our temp or our text, or basically update our text. So then that's our input, and we're going to generate the frequencies. So we can have a map as our pattern. So let's call this pattern. Okay, so what we're going to do over here is that we're going to loop through each size from A to B. And then what we're going to do next is that we're going to basically generate this string. So then we know we can basically have our starting string. So you know that string, let's call this our base. This would be equal to the text dot substring 0 to and since the substring, like the substring thing, actually the first parameter is the starting point and the second parameter is the size, and since we know our size is going to be a, this would be equal to a. Okay, so then we know that this is our base, so we can basically increment the frequency of this because we know that this is basically our base. So now we're going to loop through each character, and we're going to basically shift our base over. So then we're going to loop through from I. We can go from 1, and basically I plus a minus 1 has to be less than the size of the text, so the text size. So then we're going to alter our string. So then, actually over here we can start off at a, and then it has to be less than this. So we're just first going to pop out the first string, or the first character of the string. So base would be equal to base, or basically base dot erase, base dot begin. And then we're going to add our new character. So basically base, you're just going to add text of I, and then after this, again, we're going to increment our pattern, or our frequency for this. Okay, so after this, we're going to loop through each pattern, and then we're going to increment our frequency. So what we can have is that we can have our int, which is the number of frequency, and we can have a vector of string. So let's call this frequent. Okay, so then basically frequency of x.second, since x.second is actually going to be the frequency of this pattern, you would just push back your pattern. Okay. And after this, we're going to loop through each of those frequencies, but in reverse order. So then we're going to loop through frequency dot our begin, since we're looping it through it, and for reverse, it should be equal to frequency dot our end. Every time we're going to update the iterator over here, we're going to basically first print x dot first, or actually x, since this is a pointer, this will be x to first, and this is just going to be the size of the frequency. Okay, and then after this, we're going to print out each of the elements, or each of the patterns. So then we're going to loop through, let's call this auto pattern in each of the vector. We're just going to print pattern that, and after here we're just going to print an end line. Okay, so then since we also have a constraint that we only want to print out the n highest frequencies, what we're going to do here is that we're going to decrease the number of frequencies we counted before, and over here, basically, if we already printed all the frequencies, then we're just going to break. Okay, so that should work, and let's actually run it. Okay, so this is contact. Okay, so I'm gonna grab the text. Oh, okay, I kind of see why. So basically, since getLine is actually kind of like, it just keeps on reading a new line until there's nothing to read, and since we're using the terminal, this wouldn't work. So we can just read from the file as well. So this will be contact.in. So contact.in. Okay, so again, here's our input. Okay, so let's run main. Okay, so we're having 69, 0, 0. Okay, 45, 0, 1. Okay, so basically what we have here is that we're supposed to print out the first 10, and it has to be from length 2 to 4. Okay, so it looks like 69 zeros, and I don't think that is right since we're only supposed to have 23. Okay, so then what we can do here is that every time we increment this, we're going to say we added this base. And again, each time we added this, we're going to say that we added this specific base. Oops. Okay, again, it's still running. Okay, so we added these. Okay, so we can actually debug this. Okay, so we added 0, 1. So we added 0, 1. That's great. And then again, we added 1, 0. We added another 0, 1. Okay. So that's weird. So we actually oh, okay, I see. So actually what we're doing wrong is that we're actually not changing our size. So our size should actually be size, not A, since A is just the starting value. So over here, should actually be the substring from 0, and then the size should be at the actual size from A to B. Okay, so 23, so I think that is right. We can remove our debug statement. Oh yeah, so I think I forgot something. So when we're actually outputting, we only want to output six strings per line. So we can have a variable called done. So basically, every time we print something, basically here. Okay, so actually what we're going to do is that we're first going to print the pattern, and then we're going to increment the count we did. So if done is equal to 6, this means that we have to have an end line. So we have to see out end line, and then we'll just reset our done. Otherwise, we just print another space, meaning that we have something next to do. Okay. So after this, if we just printed a space, then it means that we can just print a new line. Okay, so that should work. And over here, we're just going to write to contact out. Oops, okay. So this is contact. The language is C++11. Okay. To desktop, this is usaco-training. And this is contact. Okay. Okay, so our output. Okay, so it seems that over here we're actually printing another space. So we're actually not supposed to do that. Okay, so I guess, whoops, so this is just some like spacing problems over here. Oh, I see, because we're actually just printing a new space over here. So then what we can do is that we can first print the first pattern, so this would be x of second of 0. And then instead of using this shorter version, we're going to loop through each I from 1 to the size of this. Okay. So over here, after this, we're actually just going to increment our done since we did an extra one. And then over here, what we're going to do is that we're going to check that if we actually have extra things that we did. So then over here, if done is equal to 6, then we're going to reset it and we're going to print an end line. Otherwise, we're going to print a space. And then we're going to print x of second of I. Okay, so I think that's just going to be like that, and we actually don't have to do this. Okay, so let me just run it, perhaps to make sure. Okay, so it would start off as 1, and then when it enters, like that. Okay, so I think this is right, since the things that I just highlighted, for example, here, there's no white space, so let's actually go submit it again. Okay. Okay, so character number 6. Okay, so we have 0, 0. Oh, okay, so it seems that we did not end with a new line here. So then, whoops, here, we actually have to print out a new line after like printing everything. So then over here there should actually be 15, and the 13 should be here as well. Okay, so again, some issues. Okay, so I guess we are not actually keeping track of all the possible ones, because I guess there is some error, because over here the correct answer would to be having 100 12 times, and over here we have 113 times. So let's actually check back here. So we have our contact. So let's actually find this. So it is 12 times. So I'm wondering why we have 13 times here. Okay, so what we're going to do is that we're going to print out our temporary string. So we can print temp. Okay, so we can print our text to our text here. So here's our text. If we actually just search from here, let's actually remove this. We also find 12 times, so there must be some missing stuff over here. Okay, so we're erasing the first character, and then we're adding character of I. Oh, so I see. So over here, this should actually be size, because we're actually starting off at size, or every time we shift, we're actually adding the position at size here. So we're actually starting from size, and we're going to increment that as well. Okay, so then when we run this, let's actually remove our print statement. So when we run this, this should actually print out the correct result. Okay, so that's 12, that's good, and 11, so that's great. Okay, let me submit this. Whoa, okay. So character number 26. Okay, so just going to look over this. So that's good. That's good. I actually don't see any difference. Okay, so we have 23, 15. 12, 11. Oh, okay, I see. So for 11, the we're supposed to print 1 1 0 0 0 and 0 0 1, but we're printing this in an incorrect order. So let's actually read the statement. Okay, so we have to order these patterns as well. So then that changes it up a bit. So I guess we could just sort this. So we can just do sort, or actually over here, sort x. Actually, I have to share this, so this should be sorting x of second dot begin, x of second dot end. Okay. So it's running. Okay, so it's actually, okay, so we are still not ordering it correctly. Okay, so we have to actually order it from shortest to longest, and then increasing binary numbers for that. Okay, so then what we can do is that we can actually have a function to compare this. So we can have this what do you call this, lambda, yeah. So this should take in a string a and a string b. Okay, this should return a Boolean statement. Okay, so first thing we're going to check is that if the size of A is not equal to the size of B, as it says, we want to return the one with the lowest size. So we want to return A.size has to be less than B.size. Otherwise, we're going to return basically which string has a lower ASCII value characters. So that should work. And I'm pretty sure this lambda thing is a C++11 thing, so in my compiler I have that, and over here it's good to have that as well. Okay, so 1 1, and that looks good. So let's actually submit it for like the third time. Okay, so main. Okay, your output 4 1. Oh, okay, so it looks like B, which is 4, and the length would be 4, but this is actually exceeding the length. So what we're going to do here is that we're going to check if size, which is basically our size of our substring, if this is greater than our size or temp size, or actually it should be our text size, then we can just break here, because you actually can't form a substring from a text that has least amount of characters or a lower amount of characters. Alright, so main.cpp again. Okay, so their output, our output. Your answer says space, while their answer says new line. So 1, 2, 3, 4, 5, 6. Okay, so that is over 6. Over 6. So it should actually be over here. Oh, okay, so actually after every single time we print something, we're going to increment our done. So then it means that we printed an extra one. So then one time we're going to print a new line. Alright, so main.cpp again. Okay, so that is right. So if you have any questions, feel free to leave them in the comment section below. Bye.